Okay, welcome back to part 2. Let's go ahead and talk about balancing a combustion reaction. What's really nice about combustion reactions, ladies and gents, is they always have the same products. Okay, it's always going to be the end of a combustion reaction is always going to be CO2 and H2O. No matter what type of hydrocarbon or acetate you have right here, it's always going to be some type of hydrocarbon. It's going to react with oxygen burning, and it's going to create CO2 and water. All right. Even though they're very easy to remember, the products and reactants of combustion reactions, they are actually some of the more difficult ones to balance. The only type of reaction that's more difficult to balance than a combustion reaction is balancing an oxidation reduction reaction, which we will do about second semester. Okay? Let's go ahead and go over this. Now, I already made an inventory of the atoms, so let's go through and count what we have. We have 8 oxygens, 18 hydrogens, and 8 carbons, 18 hydrogens, and then 2 oxygens. On this side, 1 carbon, 2 hydrogens, and 1 over here, 2 over here. That's a total of 3 oxygens. Okay, I almost made the mistake. A lot of people will do that. They'll count this one and not count the other one, or they'll count this one and not count them together. 2 right here, 1 over here is a grand total of 3 on that side. Alright, when doing combustion reactions, leave the oxygens last, because they are by far the most difficult one to balance. I always start with carbons first, then hydrogens, then oxygens. So let's do the carbons. We have 8 over here and 1 over here, so I have to add to this side. What coefficient can I throw in front of here that will multiply by 1 to get me to 8 to balance out? It's going to be 8. Alrighty. But that 8 not only changes the carbons, what else does it change? The oxygens. So we have to recount our oxygens now. I have 8 times 2 right here, which is 16, plus this one over here for a total of 17 oxygens. Alright, let's do the hydrogens next. We have 18 over here and I've got 2 over here. So what number am I going to multiply this 2 by to get me to 18? It'll be the coefficient out in front will be 9. And we're at 18 now. But that 9 also changes the oxygens. I have a total of 9 oxygens here plus the 16 that are over here. So that's a total now of 25 oxygens. Now we can balance the oxygens. But we have an issue. We have an odd number of oxygens over here and an even number of oxygens over here. No matter what number I throw out in front of this O2 here, no matter what the coefficient is, it's always going to be an even number. Okay, if I throw, well, it might not always be an even number, but it is always going to be an even number. If I throw a 3 out in front, it's going to be 6. If I throw a 4 out in front, it's going to be 14. If I throw 25 out here, well, 25 times 2 is 50, and then we're going over the amount that we need. So we need to think of this as an odd number somehow, and there's a mathematical way you can do that. Let's imagine that whatever coefficient we throw out in front, we are going to divide that coefficient by 2. Okay? We are going to divide that coefficient by 2 imaginarily. That mathematically turns O2 into regular O1. Now I'll put the 1 down there just to help you visualize that's O1. Okay? So let me repeat what I just did right here. Whatever coefficient I throw out in front here, I'm going to divide it by 2, and that mathematically turns O2 into O1. We can do this, but we're going to have to change it back later. Now that this is O1, what number can I throw out in front to make it 25? 1 times what number is going to be 25? Well, it's 25. And I can now put 25 here. Alright? And 25 divided by 2 is what, ladies and gents? That's 12 and a half. 12 and a half times 2 is 25. We are balanced. Okay? However, we cannot leave it like this. That is not allowed. We are going to have to go through and multiply by a factor that will get this 2 to disappear. Okay? And we have to multiply the entire equation by that number. Okay? Every coefficient in the equation. What number can I multiply this entire equation by that's going to make this 2 disappear? It's going to be 2. And I'm going to come down here and I'm going to rewrite the equation so you can see how the new balanced one works. We have a blank here, C8H18. We have a plus a blank here, O2 reacts to form blank CO2 plus blank H2O. Alright, let's go through this. 2 times 9 is 18. 2 times 8 is 16. 2 times 25 divided by 2 is just 25 because those 2's cancel each other out. Or you can think of it this way. 2 times 25 is 50 divided by 2 is 25. 2 times the implied 1 right here is 2, and there is your balanced equation, combustion reaction. Alright? Using the half coefficient like this is very useful when you have an odd number of oxygens. Okay? Otherwise, you really wouldn't need to do this method. If this turned out to be something like 26, then it would have been very, very easy to just go ahead and throw a 13 in front. But whenever the oxygens are odd, then doing this half reaction helps out tremendously with balancing. Okay? That is the end of part 2. Go ahead and try the summer assignment and get a hold of me on the remind.com or send me a comment on the Google Classroom and I will answer your questions as best as I can. Set 9 has already been put out, so go ahead and try that. And we'll see you back for set 10, the very last set.